Okay, so you've seen the sine and cosine curves. Now I've given you a lot of information, and here's what we're actually going to get to. What you're going to find are three things given the sine and cosine curves. You're going to find the midline, the amplitude, and the period of these trig curves, trig graphs. So first, let's look at the midline. Oops, there we go. First, let's look at the midline. Okay, it says determine the equation of the midline of the following graph. Okay, so the midline is the one that occurs halfway between the max and the min. So I see that this goes from an upper bound of 3, that's the maximum height, and a lower bound of -5. So this spans -5 to 3. So that's 8 units. The midline then will occur 4 down and 4 up. So if I'm at 3 and I go 1, 2, 3, 4, and if I'm at -5, 1, 2, 3, 4, I'm right here. So my midline is at -1. Now it asks for the equation of that line. So the equation of this line is y equals -1 because it's a horizontal line at -1. So you will put in your answer y equals -1. Okay, let's do one more of the midline. Okay, here again, midline. Determine the equation of the midline from the following graph. Okay, here we go from 1 to 3. So we go from 1 to 3. So that means that it spans 2 units. So half of that is going to be 1. So if I'm at here, I go 1, and if I'm at my lower bound, I go 1. And so my midline is right here at the horizontal line y equals 2. And you'll have to put that in delta math. Put in y equals because they want the equation. They just don't want the number. Okay, so that's how you find the midline. The next thing we're going to do is look at the amplitude. Okay, the amplitude is half the distance of the range. Half the distance of the range. Half the distance of the range. So the range here is from -3 to -1. So the range is 2 units. Okay, half of that is 1 unit. So my range, let's go here. Okay, so my range from -3 to -1, I've got a range of 2. Now the amplitude is defined to be half of that. The amplitude is half the range, so the amplitude of this graph is 1. Okay, if you want to tie it in with the midline, the amplitude, if I go from my midline to either my max or my min, that would be my amplitude. So here from my midline up to there is 1, my amplitude is 1. Here, if I go from my midline to my max, that's 1, 2, 3, 4 units, so I have an amplitude of 4. Similarly, if I were to go down, 1, 2, 3, 4, 4 units, okay? So your amplitude is half the distance of the range. Okay, let's do another one where we do amplitude. Okay, let's again find the amplitude of the following graph. Okay, now I notice that the span here goes from 0 to 4. The range is 4. So the amplitude is half of that, or 2. And here on Delta Math, you'll just put in the number 2. Okay, that's the amplitude. Now the last thing we're going to look at from a trig graph is the period. Okay, the period is how long it takes to complete one cycle. Okay, find the period of the following graph. Now here I notice that we go from a max to the next max, and that completes one cycle. Or I could look at it from here to here. Okay, notice from here, 0, to here, 6 pi. So the period of this graph is 6 pi. That's how long it takes to complete one cycle. Now notice it's given in terms of pi, not like 1, 2, 3, 4 like we're used to, but it's given in terms of pi. So the period of this thing is 6 pi. Okay, now I could pick out the period another way. I could look at, okay, so I have a period from, let me get out a different color marker. I notice that I could go from here to here. That would be another way to look at a cycle. So I'm going from 12 pi to 18 pi. Well, 12 pi to 18 pi is still 6 pi. So the period of this thing, no matter how you look at it, is 6 pi. I could even go from min to min. For example, I could go look at it from here to here. That's one cycle. So that's from 9 pi to 15 pi. Well, 15 pi minus 9 pi is still 6 pi. So if I were to look at this cycle from here to here, the period is still 6 pi no matter which way you look at it. Okay, let's do a couple more with period. Okay, determine the period of this graph. Okay, here again, I could go max to max, or I could see, okay, here it starts at 0, and then it cycles, cycles, cycles. Right there, it starts to repeat that cycle, and that's at pi over 2. So the period of this thing is pi over 2. Okay, now there are lots of ways to figure out the period. I could look at it this way. I could go max to max. Now this is 5 pi over 8. And then if I went to here, it's 9 pi over 8. So if I were to subtract 9 pi over 8 minus 5 pi over 8, 9 minus 5 is 4 pi over 8, which reduces, that cancels, and we're back to pi over 2, which is what we had determined here when we looked at the period this way. So there's a couple of ways to get the period. Oh, there we go. There's a couple of ways to get the period from a graph. Okay, I'm going to do one more finding the period, and that'll do it. Okay, determine the period of the following graph. All right, I think what I'll do is just, this is real handy, I'll go max to max. So I'm going from pi over 4 to 5 pi over 4. So if I subtract 5 pi over 4 minus 1 pi over 4, well, 5 minus 1 is 4 pi over 4, so that's just pi. Oh, okay, there we go. The period is pi over 4 to 5 pi over 4. So 5 pi over 4 minus 1 pi over 4 is 4 pi over 4, or just pi. So the period of this is pi. Okay, that's it. Now, I know I gave you a lot of background information and I might be repeating myself again, but I didn't want to just throw these graphs at you without you understanding a little bit about where they came from and why they look like they do. So that's that, and I would just like you to try finding, I would like you to do 12 problems on Delta Math. So 4 of them, you're going to find the midline. 4 of them, you're going to find the amplitude. And the remaining 4, you're going to find the period of a function. Okay, that is it. And I tell you what, we covered, like I said, we covered a lot of stuff, starting with radian. But give those 4 times 3, 12 problems a try, and we'll regroup another day, like tomorrow. Okay, bye-bye.